Hi everyone, in this video we're going to go over how we do calculations on our TI-Nspire to calculate probabilities using the Poisson distribution. Now this doesn't go into detail on how to decide whether the Poisson distribution is an appropriate distribution for your question, and making that decision can often be one of the challenging parts, so make sure you have some practice on questions where you're not told which distribution to use. But for the calculator skills, we're going to look at the question on the left. So it tells us the number of flights cancelled in an airport in a day can be modelled by a Poisson distribution with a mean of 3.2. Let C be the number of cancelled flights. Find, and for part A, the probability that C is equal to 4. So the probability that the number of cancelled flights is equal to 4. So on my calculator, I'm going to open a new calculator. I'm going to go to Menu, Probability, Distributions, and right down at the bottom, we have two Poisson distributions. We have the PDF and the CDF. Just like when we were doing binomial, PDF is when you're calculating the probability for your variable to be exactly equal to a number. So in this case, equal to 4. So that's what I'm going to select for part A. And it's going to ask me for two inputs. My lambda, which is the parameter or the mean, which I'm told in the question is 3.2 over here. And my x value in this case is 4. I want to find the probability that the number of cancellations is equal to 4. And I hit OK. And that's my answer to part A. So the probability is 0.178 to 3 significant figures. Okay, let's take a look at question B. Find the probability that the number of cancelled flights is less than or equal to 3. So I'm going to go to Menu, Probability, Distributions, just like before, but this time, because it's not one specific value, I want to find the probability of the number of cancellations being equal to. It's a range, so I used CDF because I have less than or equal to 3. So lambda, my parameter or my mean, is still 3.2. Now my lower bound, now the bounds are the possible values that C could be equal to. C, the number of cancelled flights, is a discrete random variable. So it's discrete, meaning that it can only take countable values. So you can have 4 cancelled flights in a day, you could have 7 cancelled flights in a day, but you can't have 3.5 cancelled flights or 3.2 cancelled flights in a day. So my lower bound, my minimum number of cancelled flights in a day would be none. Now my upper bound, in this case, is 3. When you're looking at the bounds are included in the calculation. So if your upper bound is 3, it will be less than or equal to 3. So it will include the probability of the number of cancellations being 3. And I hit OK. And that's 0.602. What your calculator is actually doing is looking at the Poisson PDF for 0 cancel flights, 1 cancel flight, 2 cancel flight, and 3 cancel flights. So all the possibilities and just adding them together. That's what CDF does. Next, I'm going to look at question C. So the probability that the number of cancellations is greater than or equal to 6. So I go to Menu, Probability, Distributions. And again, I want the Poisson CDF because I've got a range of possible values for C. Lambda, my parameter, is the same, 3.2. My lower bound this time, well, I want the probability that the cancellations are greater than or equal to 6. Remember, the bounds are included in the calculation, so 6 is my lower bound. Now, my upper bound. This is me thinking about what are the maximum number of cancellations that I could have in an airport in a day. And I don't know an exact value. It's not like in the binomial distribution where you have a fixed number of trials. In this case, I don't know how many flights there are in total in the day. So if you're calculating the probability of your variable being greater than or equal to a number, you can just pick a really high number. As this value gets bigger, the probabilities of having 10,000 cancelled flights is so tiny that whether I include 10,000 or 20,000, it makes very little difference. So I hit OK. And my probability is 0.105 for part C. Finally, we're going to look at question D. So the probability of the number of cancelled flights being greater than 6. Now, note this is different from the previous question because it's not greater than or equal to. So again, I'm going to go to Menu, Probability, Distributions, and it's the binomial the Poisson CDF. Lambda is still the same. Lower bound. Now, remember, the lower bound is included in the calculations. So if I put 6, it would be the probability of it being greater than or equal to 6. But I don't want 6 included because I just want greater than 6. So I go to the next possible value of C above 6. So in this case, it's going to be 7. So the probability of C being greater than or equal, being greater than 6 is the same as the probability of C being greater than or equal to 7. So in fact, we can note that in here, that this is the same as this. Okay. And again, my upper bound is some big number. The probability of the number of cancelled flights being greater than 6 or greater than or equal to 7 is 0.0446. That's it.